Hi guys, so welcome to lesson 6.2. We're going to be continuing our talk about Riemann sums. This time we're going to look at the other ways of finding area under the curve, which are typically more accurate than left and right-handed sums. They are the midpoint sum and the trapezoid sums. So a midpoint sum looks like this. You'll notice that each of the rectangles has their, instead of the left corner or the right corner being on the curve, it's the midpoint of the top of the rectangles that are on the curve. And the reason that's beneficial is because you get a little bit of your rectangle above the curve, but also a little bit below the curve, and therefore the plus and the negative areas kind of cancel each other out, and you can actually get a pretty fairly accurate measurement that way. Midpoint sums are a little bit better way to approximate it. So let's begin by practicing the art of drawing midpoint sums. As you can see, I've given you a couple blue dots here, which we're going to use as our points of interest. So we have a dot here, 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 and here. I've given you a total of 5, it looks like. Now, what we're going to do is we're going to find the halfway point between this dot and this dot. Now, what do I mean by the halfway point? Well, this dot over here starts at -3. That's too big of an ink marking. Fix that. This dot over here starts at -3, and this one ends at 1. So the midpoint would be here at -2, so I'm going to come up and put my dot right here. So you go by the midpoint of the x's there, and then the y value is the height that's at that point. And that's where I'm going to draw my first rectangle. So what about the next rectangle? So now we're going from -1 to +1. The next dot's up here, right? And we're starting here at this dot. We're going from x equals -1 to x equals 1. What's the midpoint between -1 and 1? Well, it's 0. So now that we know that, we're going to go up and we're going to put a dot there. That's my midpoint. And once again, we're going to draw a horizontal line and create a rectangle. All right. Next one. We're going from this dot to this dot now. And that's from an x value of 1 to an x value of 3. So what is the midpoint of 1 and 3? Well, that would be 2. And the y value for that is right here. So we're going to draw a length that goes from 1 to 3 with that dot in the middle. And then we're going to draw a straight line. The last one we're going to do is we're going to go from here to here, and that is an x value of 3 to an x value of 5. So what's the midpoint between 3 and 5? That's 4. Now where's the y value when x equals 4? It's right down here. So the rectangle for that, go that way so that dot's in the middle, and then straight up to the x-axis. Now we can calculate the area of each of these little rectangles drawn. So the one over here on the left, as you can see, has an area of 2. This one has an area of 2. This one has an area of 9, is it? No, I'm sorry. 6. And then this last one over here has an area of 2 times -4, which is -8. So adding these 4 numbers together, we can end up with an estimated area value of approximately 2. If you add all these up, the 6 and 2 make a +8, which cancels with the -8, so you're just left with 1 +2 there. So that would be our estimated area under the curve. Okay, now remember, it's an area that has some positive area and some negative area, so that's why it comes out so small, because pretty much what you can think of it as is like, what we're really doing, remember, is we're estimating this area right here, right, under the curve. That area combined with this area combined with this area. But this one down here and this one here, they're pretty much the same. It's just that one's positive and negative, so they kind of cancel each other out almost. They're probably not exactly the same, but they're definitely close. And all you're left with is this, and that's that little 2 that we're left over with probably. So the total area that's positive left over is. All right, but anyway, that's just me reminding you what integrals really represent. The rectangles is what we're doing. So how do we do that? You look at the x values of 2 points, you find the midpoint, and the y value goes with it, and you draw a rectangle. Let's have you guys give it a try. Go ahead and pause the video here, see if you can draw your rectangles and estimate the area using a midpoint sum. When you unpause it, you'll see the solution. All right, and there you have it. So we would estimate that one to be about 16. All right, so that's doing it with a graph given. We can also do it with a table, though. Now, we don't have to turn this into a graph, although you could. So first of all, I want you to recognize that this problem is asking us to do a midpoint sum. They want 4 equal subintervals. So how do we do that? Well, we talked about that in the last lesson. You take your last x value, and you subtract from it your first x value, and you divide by the number of intervals that they want. And I end up with 4. And that tells me how long the base of my rectangles needs to be. So, starting at the beginning here at -4, if I add 4 to that, that takes me to here, so that my first rectangle has a base of 4 spaces long. Same thing here, we're going to go 4 more spaces, 4 more spaces, and 4 more spaces. All right, now the question is, what height do we use? Well, my first rectangle is going from -4 up to 0. The height on the left is 5, the height on the right is 1, but we want the height that's in the middle, because that's the height that's going to determine the height of the rectangle. So, the height will always be the number that is in the center of each rectangle here, right? So, this height will be 3. For the next rectangle, that height will also be 3. That's in the center of this rectangle. The next one will be 7, and the last one will be 11. And we just, once again, base times height. So we have 12, 12, 28, 44, and we don't have to add all those together. We can just say this is approximately equal to, and then I'll just draw an arrow. There you go. So the area under this curve from -4 to 12, using a midpoint sum of 4 equal subintervals, would be this approximately. All right, why don't you guys give student practice 2 a shot here. Pause the video. When you unpause it, you'll see the solution. Okay, so the 3 intervals in a midpoint sum, we do last and first subtracted divided by 3 to give us 2. So we go by 2's for our bases. And the midpoint height is 8, 10, and 21. So multiplying the base times the height, we get 16, 20, and 42. And we just would add all those up. And that is our approximate answer for this particular Riemann thumb. Let's move on to talk about trapezoids a little bit. Trapezoids are another good way to estimate area under the curve whenever you aren't figuring it out exactly. And what's good about trapezoids is that since we're not using rectangles, it doesn't go over the curve or under the curve too much. Since we actually draw a diagonal line connecting one point to another, and a diagonal line will follow the path of the curve better than a horizontal line will. So trapezoid sums are pretty accurate. They stay pretty close to the actual area. So let's review from geometry, how do you find the area of a trapezoid? First of all, on a trapezoid, the parallel sides are called the bases. Now that's an unfortunate word, and I'll explain why in a minute. But they do call the parallel sides the bases. And you have 2 of them. You have a longer one and you have a shorter one. Okay. Now, the side that's perpendicular to the bases in this case is the one that we're going to call the height. Now, the reason why I think this is unfortunate is because when we're looking at our trapezoids, they're going to be rotated vertically, so they look like this. And we've been used to so far, in every problem I'm doing so far, we've been calling this the base and this the height, right? Well, that's not how trapezoids work. The parallel sides are the bases, and the bottom is going to be the height. So that's an unfortunate switch for us, but that's what it's going to be. Language we'll use. Now, when it comes to trapezoids, the area of a trapezoid is given by this equation. Area is equal to height over 2, so half the height, multiplied by base 1 plus base 2. Okay, so that's a weird formula, but there it is. That's how you calculate the area of a trapezoid. Add the bases together, and you multiply it by half the height. And that's how you find the area of a trapezoid. A lot of times they'll tell you formulas on the AP exam. I don't think this is one where they would tell you the formula. They're going to assume that you know how to do a trapezoidal sum, and so that means you need to actually have that area of a trapezoid memorized. Throw it on a flashcard and make it part of your study routine. Okay, so I like trapezoid sums whenever you're doing them when you're drawing a picture, because sometimes it's hard to draw those rectangles we've probably noticed. But trapezoids are kind of nice. All you do is for each dot, you just draw a straight line from one dot to the other, and then you go straight down. So there's my first trapezoid. Now the next one's weird, okay? The next one's weird because we go from being up here to down here. We're crossing the x-axis. And so instead of getting one trapezoid, what we're going to end up with is we're going to actually end up with 2 triangles. I really don't like how I'm drawing this. Let me make it prettier just a second. I don't like how crooked my lines are just a second. Okay, I got it fixed. So, just going to draw diagonal lines connecting each dot to the one after it. And as I mentioned, for the situation where whenever you have a dot going from above to below, what you're going to end up with is instead you're going to end up with 2 triangles instead of a trapezoid, and that's okay. It'll still work. So I've got this little triangle right here, and then I've got another triangle here. All right, and the last one, we're going to draw a diagonal line from here to here, and vertical line there. All right, so there's my trapezoids. Let's take a look at this first trapezoid. It has one base is 3 spaces long, and the other base is 1. And the height is from -3 to 1, that's 2. So the height is 2 spaces long, the height divided by 2, and then we do the sum of the bases. One base is 3 spaces high, and the other one is 1 space high. So that first trapezoid is 2 over 2 is 1, and 3 plus 1 is 4. So that first trapezoid has an area of 4. And then we're going to do that for the next one also. So the base is 1 and 4. So 1 plus 4 is my bases. And the height is 2 over 2. Now I think all my bases are going to have 2 over 2. Trapezoids anyway. So that next trapezoid is 5. Now we come across a triangle here though. So for this one, we have a base of 4. Or actually, for this one, there's 2 ways we could do this. I want to show you guys something kind of interesting. Let's do it first of all like 2 triangles. So the height is 4 of this triangle, and the base is 1. And if you're finding the area of a triangle, it's 1/2 times the height times the base. So that first triangle there is 2. The next triangle has a height of -4 and a base of 1. We're taking half of that, and that's -2. Now, if you put those together, they're just going to cancel each other out. Now, I don't want you to think that's always going to happen. The triangles don't have to be exactly the same. It just so happens that in this case, they are. But they don't always have to cancel out exactly. But I want to show you guys something kind of interesting here. You can do this like a trapezoid anyway. If you think of this first height here as one of your bases, and you think of the other height as another base, and the distance from this corner to this corner as your height of your trapezoid, even though it's not really a trapezoid, look at the same total answer. It just does them all at once. So actually, there's two ways to do this. You can just find the area of each triangle separately and then add them up, in which case you get 0. Just negative 2 is 0. Or you can just do, okay, height 1 plus height 2 times total base and half. You get the same answer, actually. It's kind of interesting. So it doesn't really matter how you do it. But anyway, last one is a trapezoid. So this last one has a height of negative 4 and another height of negative 1. So we have negative 4 plus a negative 1, and once again a base of 2. Or I'm sorry, a height of 2. And that gives me a negative 5. And if we just add all these little areas up now, we'll be good to go. 4 plus 5 plus 2 minus 5 leaves me with a total area of approximately 4. Okay, now the true area under this curve is much more than 4. It's just that whenever you include negative areas, it cancels them out, right? So there is our answer for that. So why don't you guys go ahead and give trapezoidal sums a shot here. Go ahead and draw your trapezoids, find the area of each trapezoid, and find your total area. When you're done, you can unpause the video and you'll see my solution. All right, so I had 1, 2, 3 trapezoids and 2 triangles, total area of 13. Okay, same thing, but we're going to do it with tables now. So how do we do this? So we're finding the area under the curve of f of x from 0 to 8, and here are the points we're going to use. And usually up here we call these our bases, right? But with trapezoids it gets flipped around. So this is actually going to be our heights. So this is the up here. Let me rewrite it here. These are our heights. So from here to here, my first height is going to be 1. My next height is going to be 1. My next height is going to be 4. And my next height is going to be 2. So not all the trapezoids have the same height in this case. All right, now the y values represent the bases. So this is like for my first trapezoid, as I'm going from here to here, this would be like base 1, and this would be like base 2. And there's its height. So we have base 1, base 2, and height. So if I wanted to calculate this, it would be height over 2, the sum of the bases. And we're just going to keep doing that. So for the next one, we're going from here to here. So my next trapezoid would be from x equals 1 to x equals 2. That height is 1. And base 1 and base 2 would be 9 and 8. So height is 1 multiplied by the sum of the bases. Next one, we're going from x equals 2 to x equals 6. And that height is 4. And the bases for that one are 8 and 7. So my next one is going to be a height over 2 multiplied by the sum of the bases. And then we got one more. We're going from x equals 6 to x equals 8. That one has a height of 2. So it's going to be height over 2 times the sum of the bases. That's 7 and 5. So I've got 4 trapezoids that I'm calculating the area of. And now technically, if you wanted to, you could even just leave your answer like this and just draw an arrow straight to there and say, okay, this is approximately equal to that, if you want. That would be fine. I'm going to go ahead and simplify just because I feel like it. This one is going to be 8. This one's going to be a ugly number. I think 8.5. This one's going to be 15 to 30, 12. And you can even add all those up if you wanted to. But really, just actually When I told you that you can count this in the answer, yes, you could, but you definitely don't want to forget to put pluses here. If you forget the pluses, then the people grading your AP exam may wonder, does this person really know you're supposed to add all these together afterwards? So this is an acceptable answer, and you can totally leave it like this. If you want to go all the way, go ahead, but this saves you time and also possibly making an error. Just don't forget your components there. That is a trapezoid sum with a table. So up here you have your heights, and then for each pair you do base 1, base 2. And then each number gets used twice except for the endpoints. Then it's base 1, base 2. And then it's base 1, base 2. And then it's base 1, base 2. So let's see how you guys do. Go ahead and try this one here. And when you unpause the video, I will show you my solution. Alrighty. So I've got 4 different trapezoids here that I've color-coded. So for the first one, the height is 3. The bases are 6 and 8. So that's the area of the first trapezoid. The second one, the height is 2. The bases are 8 and 7. The third one, the height is 2. The bases are 7 and 5. And the last one, the height is 1. And the bases are 3 and 5. And there's all their areas being added together. And that is an estimation of the area under the curve. And we don't need to simplify this. All right. So there we go. Let's move on to example 5. So this is the one where instead of giving you a table, I give you an equation. And so in those cases, you have to create your own table. All right, so for step 1, we're going to start by finding our bases. Okay, and that's the thing where you do the last x value minus the first x value divided by the number of subintervals. So 6 minus 0 over 3 2. So we're going to be counting by 2s starting from 0 up until 6. And so now we're going to make our table. Now when you make the table with these midpoint sums, the table's a little bit trickier. For midpoint sums, you need x values in the middle of each pair. So I'll show you what I mean by that. Let's make a table. Now I want to start at x equals 0, and then I want to go by 2s. So my next number is going to be a 2. But I need the number in the middle there, because when you're doing a midpoint sum, we need that middle x value. Okay? So let's keep that up again. The next x value, if I add 2, will take me to 4. But with midpoint sums, you need the number in the middle. And we'll just kind of keep doing that. Add 2 more. And don't forget your middle number. Okay? And so there's the x values. We're going to do 1, 2, 3, 4, 5, 6. But really the bases of my rectangles are going to be 2 spaces long. But we do want to use those. We're going to need those blue x values in just a minute. So there's that. Now the next thing we do is get our y values. So step 3 is going to be to find the midpoints. But when you're doing this, we really don't care. And think back to when we did a table earlier with the midpoint sum. We really didn't care what the left-handed endpoint was or the right-handed endpoint in the triangle. What we really cared about was the middle one. So we don't really need to find the other x value or the other y values. All we need is the ones that are in the middle. So we're going to plug 1 into our equation up here. And I get -8 as a result. And so I really only care about that y value. And for the next one, the next midpoint is 3. So I would plug in 3 to get that y value. And for that, I get 0. And the last midpoint that I care about is 5. So I'm going to square that one also. And for that one, we end up with 6. And so what we have now is we're ready to do the last step, which is to calculate the areas. So let's do that. we have our base is 2 and our height is -8. So my first area is going to be -16. Base is 2, height is 0, so we have a flat rectangle, no area. And then base is 2, height is 16, so 2 times 16 is 32. And then we would add all that up to get our area approximation, which is 16. So this integral up here would be approximately 16. So let's review. How do you do a midpoint sum to estimate an integral whenever they give you an equation? You need to find your bases by using however many rectangles they want, using this formula. You're going to set up your table going by those distances. But we do want to include the midpoints in our table as well, because those are the y values that we actually need to include to find our heights, which is step 3. Once you have your bases and your heights, you're ready to find your areas, and you're good to go. So I'll do one for you guys here. Go ahead and try to do a midpoint sum to estimate this integral, 4 to -4 here, using 4 subintervals using this function. When you unpause it, I will show you my solution. All right, and so here's the solution. Step 1, last x minus first x divided by the number of subintervals is 2. So we're going by 2s, starting with -4. So -4 to -2 to 0 to 2 to 4. But we do include the x values in between each of those, which I've highlighted in blue here. And then we plug those blue x values, the midpoint x values, into our equation up here to find the y values that go with each of them, and those represent our heights. So up here we have our bases, here we have our heights. We multiply the base times height, and we get 14, 30, 30, and 14. Adding those all together, we have a midpoint sum using 4 subintervals to estimate this integral. All right, so that. We could do the same thing with trapezoid sums. So let's go ahead and see how do we make a table for that. That one's going to be a little bit less tricky. The midpoint sum thing's a little bit tricky because you have to include those middle points. But with trapezoids, they're kind of like the left and right hand sums. You don't have to add any extra little things in there. Just kind of work out the way it's set up. So let's begin here. So once again, the first thing you're going to want to do is you're going to want to find your bases using the strategy that we've talked about before, which is last x value minus the first x value divided by the number of subintervals. And once again, it's 2. And then we're going to move on to step 2. Once again, that's to make our table. And like I said, this time making the table will be a little bit more straightforward. It won't be as challenging as the last one. We're going to start with our lowest x value, and we're going to go up by 2. So the next one's going to be -1. Going up by 2s, the next one's going to be a +1. Going up by 2s, the next one will be 3, and that's where we stop because that's my highest x value. And then we find our y value the same way we found the y values earlier. And that's just by plugging it directly into the equation. So if I plug in -3, I get 0. If I plug in -1, I get -8. I get -8 here, and I also get 0. And then finally, we're going to calculate our area, and this is where the trapezoid does get a little bit different. We are doing a trapezoid sum, right? So since this is a trapezoid sum, we're going to have to use the strategy for calculating trapezoid areas that we learned earlier. Okay, so all my heights are 2, because that's what this is. Matter of fact, for this step 1, maybe we should call this finding the heights, because with trapezoids it gets reversed. So call this finding the heights of the trapezoids. So for my first trapezoid, my height is 2. We're going to cut that in half. Then we're going to do our two bases, which the first two y values are 0 and -8. Plus, and then we do the next one. Then we have the next height is 2, and the next two bases are -8 and -8. So height over 2, -8, -8. Next trapezoid, height is 2, divide that by 2, and then my last two bases are -8 and 0. And we can just leave our answer just like that. We can go ahead and circle it and say that's our estimation for the integral area of the curve. All right, so we'll let you guys try one of these. So go ahead and pause the video, and when you unpause it, you will see the final solution. Okay, for step 1, the height of each trapezoid is 1. You do 2 minus a -2 divided by 4, and that gives you 1. And that means we're also counting by spaces of 1. So starting with -2, we go up 1 to -1, then up 1 to 0, then up 1 to 1, then up 1 to 2, and we stop at 2 because that's the last x value. Plug in all these x values to find the corresponding y values. Then we have our height multiplied by the sum of the bases, cut in half, and you do that for each pair. And then here's our 4 trapezoids that we have as a result. Adding together those 4 areas gives you the estimation. And on a free response test, like I said, just leave your answer like this. There's no need to go further. But if you have a multiple choice test, they probably wouldn't write their answer like this. They'll probably have it completely simplified. But let's not do it if we don't have to. Just a lot of time. Anyway, so I think that concludes our lesson for the day. So we'll call it quits there. That was the last of our Riemann sums. And so, chapter 6 is all about what is an integral. Well, an integral is area under the curve. And what we're doing right now is we're finding a geometric way to estimate the area under the curve. Okay, so that's it for now. And we will continue our chat about what integrals are in our next lesson.